So we need to find first the second derivative and the position vector, meaning we're going to need to find the integral. Well, first, we're just going to find the second derivative. We're going to go ahead, find the first, and that's just 2t cosine t minus cosine t minus t sine t, which was the derivative of the cos of the sine and then the product rule between t and cosine t. And then the last one, which is going to be negative sine t plus sine t, which is another product rule that we have. And that finishes off. Simplifying this, we get 2t minus t sine t, and then t cosine t. Here we need to find the second derivative, and the first part will be the derivative of 2t is just 2. We have another product rule, so we'll end up having negative sine t minus t cosine t. We have another product rule, we have just cosine t minus t sine t. And that is our first answer. Now the integral is going to be a little difficult because there's lots of by parts. Integration by parts. So we're going to go in couples of steps. We know that to get r, we need to take the integral of vt dt. Remember that by parts is u times v minus the integral of v du. So we're going to go ahead and find the big integral, the one that we need to do. So 2t so we can go ahead and split it up, the integrals. So we'll have the integral of t squared dt plus the integral of sine t minus cosine t times cosine t dt plus the integral of cosine t plus t sine t dt. So we're going to go ahead and break it up. We're going to label this equation 1, this will be equation 2, and then this will be equation 3, just so it's easy to follow. So for equation 1, it's really simple integration. We have t squared dt, we end up getting t3 over 3 plus c. Now we're just going to label the c1 for equation 1. Now we're going to move on to the second part. So for number 2, we see with number 2, we can break up the big integral that we had here into even smaller integrals. So we're going to go ahead and do that just to make our lives easier. Here's where we'll be using the by parts. So the first integral is pretty straightforward, just the integral of sine, which is just negative cosine plus c. And now we move on to the biparts. Remember that biparts is u times v minus integral v times t u. So we're going to go ahead and call u is going to be equal to t, which makes our du dt. We're going to say that our dv can be cosine t dt, and our v is going to be sine t. I'm going to go ahead and plug in our formula. We're just going to have sine times t minus sine t dt. Go ahead and integrate sine t, and we just get t sine t minus, well, when we take the integral of sine, we're going to get negative cosine, which makes positive to negative makes positive, plus c. We're going to go ahead and combine the two that we got for this one section. And we're going to go ahead and say that negative cosine t minus t sine t plus cosine t plus c2, which is just the two c's together for equation 2. And when we simplify this, we get negative 2 cosine t minus t sine t plus c2. And this is for equation 2, for the second integral. We're going to go ahead and do the third one now. The third one was the cosine of t dt plus cosine of t plus t sine t dt, which we can again break up into smaller ones. And we will have another biparts here. Go ahead and solve the simple one first. And we end up getting integral of cosine is just sine t plus c. And now we have biparts again. So we are going to say that u again is going to be equal to t. du will be dt. Our dv will be equal to sine t dt, and our v will be equal to cosine t. I'm going to go ahead and plug it into our equation. So we have t times v, so t times cosine t, minus the integral of v cosine t times du, which is dt. We'll go ahead and simplify all this out. Oh, my mistake. The v is negative cosine. Can't forget that. Super important, which changes the signs. So we're going to go ahead and integrate cosine t dt, which just gives us sine t. Go ahead and plug that back in. Cosine t plus sine t plus c. And we're going to go ahead and put them back together. So we have sine t plus sine t minus t cosine, which just gives us plus c, which just simplifies into 2 sine t minus t cosine t plus c, 3 for equation 3. Now we're going to go ahead and put the whole thing together. So RT is just equal to the integral of the first equation, which was t3 over 3 plus c1. The integral of the second one, which was negative 2 cosine t minus t sine t plus c2, and then 2 sine t minus t cosine t plus c3. And that's our answer.